Hi, good evening, everyone. Am I audible?
Yes.
Yes, sir, we can hear you.
Yes, sir.
Yes, sir.
So, today is the last session. We are going to cover some advanced topics of Pandas. And I'm going, before we go to those topics, I'll just briefly cover a few of the points from the last session, which I think should cover. And before even I start covering anything, do you have any questions till so far?
Yes, sir.
Sir, why can't we just simply copy a data frame like df2 is equal to df? Why do we use dot copy deep is equal to true?
Okay, great question. I'm going to come to that. One minute. Let's do that. See, so I think the D equal to true has very similar meaning in creating a copy as well as creating or getting the memory usage of any data. So let me cover the memory usage. It's very similar to uh, application in copying a data. So as usual, import numpy and data pandas. I'm just using the previous session's data frame. Okay, I'll come to the saving part and so on and so forth. But let's look at it right. So if I look at df.memory, memory usage, it is going to give me something like this. Let's look at df. Now pay attention to the data types, right? So the first two columns are strings or in pandas they are objects, and the last column is integer, right? So the last column is a basic data type, but strings are basically are made up of collection of characters. They could have different lengths also, and based on that they consume it. But here you are going to see that all of them, 1, 2, 3, all of them are consuming. I mean, both first two columns, every entry in those two columns is consuming 8 bytes, right? 8 plus 8 plus 8. 8 plus 8 plus 8, right? So this is consuming 8 bytes, this is consuming 8 bytes, this is consuming 8 bytes, and this is also similarly, these three are consuming 8 bytes each. And therefore you are seeing 24 bytes. An integer, okay, by default, I'm pretty sure that price index is being represented by int 64. That's why we are seeing 24 bytes for that column also. However, that is something incorrect, because not, I wouldn't say completely incorrect. That's the default behavior of memory usage API. It is going to give you the superficial memory usage. It will not go in depth and look for each and every object in every cell and then compute its use how much memory is being consumed by that cell, and thus sum it up for every cell. It's not going to do that. But if you want to get that, you have to use deep is equal to true. And as soon as you use deep is equal to true, what you're going to see is okay, index memory consumption by index is still the same. Memory consumption by price in lakhs column is still the same, 24, 24. But here you can see that manufacturer and model, these two columns, the amount of memory usage is more, right? The reason for that is this time when we said deep is equal to true, it's going to take into account the memory consumed by each and every object in the cell, not just the reference in the pandas data. And therefore, this gives you true memory consumption. In case you have non-primitive data types in your data. So this is use this deep is equal to true when you have more complex data types in your data frame. They are just primitive, boolean, just pinpoint numbers. Then this is sufficient. Does it make sense? All right. Coming to the question that somebody asked, if we copy with deep is equal to 2, what's going to happen? it is going to make a copy of every object inside the data frame. Otherwise, it's just going to copy the data frame, but will not create the copies of individual objects. I hope it is clear.
Yes, sir. Thank you.
Just few points I wanted to cover from last session. For example, how to save a data frame. It's a very simple thing. For example, if you this is how you do it: data frame dot CSV, and the path where you want to save it to, and give it stars.csv. I'm checking is index equal to true, which is by default the uh, true is default value for index column. That means whenever you save it. Now let's look at it. Tab content stars.csv. So here you can see that manufacturer model pricing lags. There's a right comma. And there's a first value. There's a comma before manufacturer, but there is no name of the column because it's the index column, right? And it is being saved. Many times what you want is you do not want the index column to take a lot of space, or you want to ignore it. So what you can do is you can set it to false. Okay? And if you do that, the index column is gone. Okay. Now, if you read the CSV file, now if you read the CSV file now, it's automatically going to take default index, which is 0, 1, 2, 3, so on. There is the index column is not coming like this. However, let's say you forgot to set it to false, you set it or left it false value, saved it, right? Then if you read the CSV file, this is the problem you are going to see. It's going to assume that the column name is missing, but there are some values in the column. And therefore, you are seeing that 11, 12, 13 as a separate column, and the index is 0, 1. However, in many cases, you want to preserve the index. Then in such case, what you can do is you can mention which column is your index column, and you can mention the integer index of that particular column, which you want to treat as Pandas index, something like this. And when you read it correctly. 11, 12, 13 is no name column. There's one more thing that you can do, which is okay. There's one more thing you can do, which is you can select the column that you want to load when you're reading the 60. Okay. So the name of the parameter is these columns. Now here you can provide the either indices of the column 1, 2, 3, or let's say 1, 2, or you can provide the names. For example, model and here it is. Now there are only two columns, and index column, even though we have mentioned it like this, but since we mentioned it, it's complete. Let's move forward. This one as well. All right. Now coming to the main topic of today's session, which is aggregation and reshaping the data. So let's start with this. For this, I'm going to upload a CSV file. Am I audible?
Yes,
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 sir.
you are.
Sure. Okay. Now, for this, I'm going to load CSV file, which is slides.csv. This file you can find in the folder shared with you, the supplementary content. From there, you can load up this file. I have already loaded it. Now let's read and see. See what's in there. Alright. So there's a bunch of columns, and this is flight's data set. So it tells you which month the flight was scheduled on. Day, which date was airline name, I guess. Origin air, I believe this is the name or location of where the flight is started, and this is the destination. This is scheduled departure and how departure delay, arrival time, distance, scheduled arrival, arrival delay, whether it was diverted or not, whether it was cancelled or not. So like 0 is for it was not, that means 0 is false. Is 1, then it is true. So this is our data set. Now, see, many times you will there are 8,000 rows. Many of the times you want information which can be computed by aggregating something here and there. For example, you want to find out which airline was the most popular. Of course, you can do that by just simply lines underscore here or value pounds. This is not good. So what's in the okay. Something like this you can figure out. I don't know what is the full form of this term. Is it delta or something else?
Use
But it is
Delta,
some
American Airlines, and others. Delta.
okay. Okay. I wasn't aware of this, but thanks for informing. So delta is the most popular one. That means it had most number of lines in this data set. Okay, this is something very simple that you can find out. But what about you want to find out the average delay of any particular airline, every airline, that's it. And then you want to probably make an informed decision which airline you should choose, something like that.
Sir, I can
For that,
suggest one thing. I was
yes,
part of travel and transportation industry in IBM for nearly a decade. So a good example of there would be in a data set. If you look for day of the week as one, in America, Monday is considered the weekday one. In India, Sunday is considered the first way. And see departure time morning around 6 o'clock. A lot of people take the morning flight to go to the city where they have to work or consulting work, and then they come back in the evening. So any day one morning 7 o'clock departure, that means 0700 will be the most occupied and most frequently used and most profitable flight. So that's a bit of domain expertise I can give insight into. And that's the most competitive market. Everyone wants to depart at 6 o'clock in the morning because
uh,
that's when they get the most passengers in the Monday morning 7 o'clock flight.
okay. Yeah, I think we can do something like this. So, okay, arrival time, air time is this much. Scheduled departure is, I think it's okay. See that I don't mind doing that, but that's going to be a little more tricky exercise. For example, because we will have to convert scheduled departure as well as yeah, scheduled departure basically. We are just looking for how many flights which is started at 6 a.m. around. Okay. For that, we will I think since it's just numbers, it should not be that. Okay, so what do you want to do? You want to look for the flights which start at 6 or 7, right?
Yeah, flights that depart between 6 o'clock in the morning to 7:30, because people have to be at office by 9:30. So they have to depart by 6:30. That means they should be one. Departure time should be between 06:00 or 05:30 to 6:30 or 7 at max. The flight should depart because it will land after an hour, and then they will take half an hour to come out of the airport, and then they have to go to the office. So departure should be between 5:30 till 7, and day of week should be one, and which flight has the least amount of variance in delay. So if you are a working professional, you will select that flight which has the least, on an average, least delay in minutes. Like Indigo in India has the least delay. It's known for on-time performance. So those
Okay.
are some of the stuff.
Okay, sure. So I was just looking at the data type of scheduled departure, and turns out it's integer, so we can easily know. So, nothing further, nothing further conversion. This. Uh, okay. So okay, let's. So do you want to do only for the flights which start? I mean, depart between 6 or 7:30, or for the entire data set?
That will give you the very good insight, because that's the most occupied market, as well as Friday evening. Friday evening flights are very expensive because everyone tries to go away to something. So if you want
Right.
to test the profitability or utilization or efficiency of something, Monday morning and Friday evening, they are the two best times to check any airline.
Okay, we'll check that. Uh, But before that, I just want to introduce the concept of aggregation, because your question very valid. However, it's an application of aggregation. We'll come to that also. Okay? But before that, I just want to introduce what's aggregation to everyone, and let's see some examples and then come back. So, load the flights dataset to get mean leader per flight per airline. See, now what you want is you want to aggregate information. Looking at the question, get the mean delay per airline. By the way, there are two types of delays. Uh, Departure delay, I believe it's in minutes, and arrival delay. This is also in minutes, and you can see some of them, some of the flights reach the destination earlier than designated. But that's fine. But what we want is, for every airline, we want to find out the mean scheduled departure delay and mean arrival delay. For that, what we need to do is we need to divide the rows into groups, and each group must have a single airline, right? That means we are selecting all the airline, all the records belonging to one particular airline, then put them together, then pick next airline, pick all the records for that airline, put in the next group, and keep continuing doing this, right? So this is what we want. Let me do one. Something else. So what I've done is I have sorted them in increasing lexicographical order of column airline. So you can see the top is A and the last is W. However, this is very cumbersome, right? Do it one by one. There could be. Let's find out how many unique values or unique airlines we have in this data set. Right? We have seen it somewhere, but it's, yeah, there it is. So maybe 50. So there are 14 unique airlines in this data set, and of course we cannot do it now. For that, for such kind of operations where we want to put the records into groups and then perform some kind of operations, can use group by. That's what I'm going to test. So group by, you're going to choose the column or set of columns. I'll come to column, set of columns also. The column by which you want to group it by. If I group it right now, it's going to give me a group by object, which I'm going to come later and inspect it in more detail. But for now, this is what we get. Let me save it like this. Right? Group. Now, what should I get? This grouped object must have separate groups for each and every unique airline. This is what I want. Now let's take a look. We can identify that for name, comma, group in group print name, comma, dot. I'm going to explain this what this statement is. Or something more. Name of the airline, and I'm going to create a new line character. Now let's take a look at this. So it is saying that name of the airline is AA and the data inside the group is this corresponding group. Then name of the airline is AS and the data inside the group is up to here. Similarly, name of the airline is BX, B6 and so on and so forth. So basically it is doing what we want to do. It is creating groups. You can double check this one. For example, flights. Instead of grouping by query and airline is AA. And let's see what records do we get. It has many more. Or it has many more. The reason for we are not seeing many more is we are using head 3. That means it is going to show only 3 rows for every group. But it has 8900. We can, instead of calling this, we can also use shape. You can see that for airline AA, there are 8,900 rows, and that's what we are seeing over here also, right? Very good. Right? So it is doing what it is supposed to do, right? That is, it is creating groups. Okay. Now, creating groups is always the first step. The next step is picking the columns that you are interested in, picking the features. We are interested in airline, and then performing some kind of operation. Right now, I'm interested in performing the mean of the delay for every airline. Okay, let's see how. So schedule departure. Let's say we talk about only departure. Query this, then I create departure delay, then compute mean. Okay, let's see what is the output. It's turning around to be 11 point something like that. Why did I compute this right now? Because so that we can later confirm our output in the back operation. So instead of this, goodbye. This is the column I'm interested in. There are multiple syntaxes that you can use to perform the group by and any specific operation. This is the one that I'm showing you to you right now. we are grouping by the entire set of records by airline. Then I'm only interested in departure delay. The rest of the columns will be discarded. And for every group, I want to compute the mean of this column. Okay, let's execute this. You can see that for airline AA, I'm getting 11.275, something very similar. Yeah. Exactly, nearly same value. Only trying. This one is has more number of digits after decimal. This one is less, but the values do match. Okay. So this is one way you can do that. Now, any questions so far? All right. So this
Excuse me,
particular. Go ahead.
Excuse me, sir. Sir, you did that with that for loop. You did some iteration, no? Just for doing this separate groups of airlines.
This is the
with the name and two things for name and group DF. So this name, how it is coming? It is the name of the airline, no?
That is correct. Name of the airline.
So then how it is getting in group?
Okay. Okay, I'll tell you. So basically, you can think of it like a, so not exactly, but you can think of it like a dictionary, right? Where name of every airline is the key, and the value is all the records that belong to that airline.
Okay, but how that column was selected for just when we write name, how we are getting this airline?
Look at line number 43. So can you please scroll up line number 43? We have grouped by airline now. 43, just about 43. Yeah, that one.
Oh, here we have already grouped it.
Yeah.
Oh, okay, okay, okay. Okay. Oh, that's why when we are getting like that. So we are iterating in the grouped one.
Correct.
Could you please print that group variable?
Group? Sorry?
I'm saying that could you please print that group variable?
Okay, I did not hear that clearly.
Hello, sir.
I should do what?
Could you please print group variable? Group that where there is
Sorry, your voice is not clear. Can you please type in the question? Okay, meanwhile, question is coming. For 1 minute. So see, this output. By the way, let's save it somewhere. Is equal to this. Let's look at the type. The type is series. Keep this point in mind. We are going to be very sensitive about type of data or operations. Now let's look at another way in the same thing. You have done the grouping by here. Now you want to do aggregation. For that, there is a method called AGG. Inside this, to provide a dictionary of things. I'll tell you what are those things. First thing will be the column name on which you want to perform the aggregation, and second will be a list of operations. Okay. Now let's see. So column name we are interested in departure delay. Then list of operations. Right now I'm only interested in I'm going to write the name. Now, good thing about Pandas is either you can write mean like this, and by default, it will understand you want to perform the average, However, you can provide a specific function also. For example, np dot mean. That means take the mean of the column. This is also acceptable. Both of them are going to be same answer. Another thing that I could have chosen is, let's say, median. Okay, now let's see the output. So what I want to do is I want to perform aggregation by airline. Then I want to take the column departure delay and then compute mean of that column as well as median. There it is. So departure delay, this is the column I'm interested in. Airline. Now you can see that airline is coming like this. Go back to this one. The mean and median. Since you are providing two functions over here, therefore you are seeing two columns over here. What is the mean? 11. What is the median? -2. That means nearly 50% of the nearly 50% of the flights fly on time, or 2 minutes earlier, 5 minutes earlier, 5 minutes earlier or more, 2 minutes earlier or more, and 0 either on time or earlier, and so on. So only this particular airline, this one and this one, the median is 1, means more than 0. They do get delayed. And the mean, you can see that the highest mean is for some or no. Yeah. So this airline, the flights for this airline get delayed most on an average. So this is the information that you can get. And please note that departure delay, mean and median is over. Please note the syntax. AGG, because we are going to use AGG a lot more. It is more powerful than how it looks as of now. I could have used something else also. For example, so in this dictionary, we are providing just one column. Right? What if I want to do the same thing, but for arrival delay as well? Okay, so let's write it. For arrival delay also, I want to compute in median. So there you go. Arrival delay, most of them are reaching in time, kind of. On an average, okay, there is some delay. On an average, okay, this one takes to the destination earlier than designated time. This one takes 5 minutes more, nearly 7 minutes more, 30 minutes more, so on. And top of the table, top of the data frame, you can see that there are two columns that we are interested in with the partial delay, arrival delay, and mean and median for both the mean and median. I can do sum also. See this. I've done summation as well. I can do few more. For example, count also. I want to count the number of records. Then so you can see the count of number of records for every year. So you can see that Delta is very popular. There are 10,000 records for this airline. The next one is What is that? But the point being, you can do many types of aggregation for every column after you do. Any questions so far?
So a business insight here could be that if say departure delay is more than 120, for how many instances of departure delay has been more than 120 minutes? Because usually beyond 3 hours or 4 hours, they have to give a lounge facility or they have to accommodate someone there. That becomes a big cost to an airline. So how many times the departure delay has crossed 90 or 120? That is a big business decision. Yeah.
Yeah, we can do that. So for example, departure delay. It's better if you use departure delay is greater than or equal to 120, is it?
Yeah, in some airports, in some government, state government is 90, otherwise 120 is universal rule. In India as well.
Okay. Let's say you can do count. Rest of the things are not. or anyway, let's so you can see that AA has most number of because it was popular also, no? AA and Delta. Delta has 122 such instances where the delay is more than 120, departure delay is more than 1. So you can see that the mean everywhere is more than 120 minutes and median is 160 minutes. Yeah, so something like this we can figure out. I can give you a better question. Right? What is the percentage of such flights? Not just 203. So 203 and 122 might seem large for us, but you have to normalize it with the number of flights belonging to these two airlines. That will give you a better understanding of how punctual they are, rather than just looking at the number of count of flights. And I'll come to that. That's a very interesting question. Probably I'll show you how to do it. Because that, if you want to compute that, that's not based on just a single column, right? It is based on, of course, you can do it on based on single column, but what you need is not only just the count of flights which were delayed 120 minutes or more, but also the total number of flights for that airline. We'll come to that.
So that may not be true because if you go deeper, because if something increases by scale, then that problem has to be endogenous. That means if the organizational culture is bad, then as the number of flights increases, the number of delayed flights will also increase. But if the delay is due to weather or not getting slots, then as the number of flights increases, number of delayed flights will not increase because that is not due to the airline. Then the volume will not drive number of delays. Yeah. But yeah, it's a fair call that as more flights, then definitely. So suppose SpiceJet has less flights and Indigo has more flights. That doesn't mean that Indigo will have more delayed flights. If the reason for delay is not because of delay in the operation of Indigo, if it's delay beyond their circumstances, then it will not increase by the number of flights. But anyway,
Yeah, of course.
It's a fair call. Yeah, fair call.
We can further dissect this data set and find out what are the destination and origin of flights which might possibly causing this delay. But that's another story, right? But just by looking at that 203, this is the highest. This has the highest count of delayed flights. We cannot say this is the bad flight. This is the bad airline, and you should avoid it. You cannot make that.
Excuse me, sir.
Yes.
If I were to use the log function on this data frame, how would we reference the columns? Because two columns have the same name, and so do the two others.
Very good question. Very good question. But at this moment, I do not want to get into multi-level column names. I'll show you the, anyways, this right now, selecting this is tricky. So I'm going to show you a trick which will make it easier for you. Okay?
Yes, sir.
And for that, we'll look into this aggregation function a bit more. Alright, so far we are here. And as Shivani has pointed out, that there is a problem with this data frame because it's not easy to manipulate. Furthermore, let's see it somewhere. Delayed flight if is for this, and I'm going to reuse this. Let's look at the now the column names are actually tuples. Departure delay, that. Departure delay, that. Arrival delay, that. Arrival delay, some of that. And there's one more thing. If you notice, there is no column for the airline name. Instead, you will find it over here. There are 14 values and 14 entries starting from AA, which is a flight airline name, W. Okay, so first airline name to the last airline name, they have been converted into. So these are the column names. If you look at the index, these are the index values, AAAS. So by default, whenever you perform the group by operation, you are going to get index, whatever the columns you have chosen, perform group by, here we have chosen line. The values for that column or that set of columns will become index. And probably this is not the desired behavior most of the time. You want to convert this index as a column. So there are a couple of ways to do it. If you do, you can solve this problem. Make sure that the airline names are in a column and not in an index. There are two ways to do it. So first way is to look at the when you perform the group by itself. So CG should also be here. Something like this looks better. Now, when you're performing a group by operation, by default, the columns that you have chosen will become X. But if you do not want to do it, then you can set as index equal to false. Let's run this. Okay. And then let's look at the output. And here you can see that now there is an airline column and the indexes are 0, 1, 2, 3 up to 40, up to 30. Okay. We can double check this by looking at columns. See, the first column is airline, right? Earlier it was not the case. And if you look at the index is integer now. Earlier it was looking something else. Okay, so this is one way to make sure that the grouping columns remain as columns and they do not. There's one more way to do it. So I'm going to remove this one. Execute it. This is the data. There is an operation called reset index. There it is. Now what you can see is whatever the index column is to point that the index, the column, the vertical list, whatever was there has been now converted into a column. Right? It is not no longer an index. It has become a legitimate column. If I look at the list of columns from this data frame, I'm going to find that headline is long. Any questions? Okay, let's move on then. So multiple ways to aggregate. We have seen a couple of them so far. By more than one column. Let's do that. By more than one column. Airline we have already seen. Yeah, let's see origin of the flight and departure of the. So original destination. Okay. So these two topics. Let's try it. Since we are providing two columns this time, we have to provide a list rather than a single column name. I think this was the first column, and next column was this. See if it works. It is working. And of course, if I just do this group by, it's not going to show me how I have to perform some aggregation as well. So let's say AGG and what operation should I choose? Okay, let's see if any particular pair of origin and destination has highest number of cancelled flights. That's it. I'm going to choose. Then sum. Let's see. Again, since I have not used by default, the different columns have become index, multi-index, and which I am not, which I don't want. So what I will as false. And again, this is not very useful information for me because there are many tests, and I want to see the most popular pair for the flights to get cancelled. So I'm going to sort values by cancel. So there it is. So now it is giving me the source and destination pairs for which the most number of flights were cancelled is this one. SFO is San Francisco, LAX, I'm not sure what it is.
Los Angeles.
Los Angeles. So 18 flights for this pair. Most actually for this pair. But there's another option for this. See, ascending is equal to what it is false. That means you want to see the sort the data frame in reverse order, in decreasing order. So you can set something. So this is how you can actually use multiple columns for grouping.
So this aggregate after cancelled colon sum, what why it is colon sum?
Okay. So what we want to see cancelled, it is 0 if it is not cancelled. It is 1 if the flight is cancelled, right? So what I have done is if I do something like this, just this. So I'm going to get cancelled is the name of the column. This is show you how we can change this. But right now we are interested in aggregating based on the column cancel, right? And how do we want to produce the aggregate? By summing it up. So all the values for that particular group, I want to sum it up and put it over here. Okay.
Generally, yes, that I understood. But actually, we used to do this dot sum means here it is colon sum. That is the only thing. This is the syntax.
Yeah, syntax. See, this is you can remove the basically what you want to provide is a function over it, not necessarily import sum, median, count, mean. These are such default functions that you can provide in ports. However, you can provide custom functions also over here, which I will come to later. Okay, you can provide it something like this as well. So I'm interested in column plus cancel, and then I'm only interested in producing or applying one aggregate function which is sum, and then let's look at the problem. That's it.
Okay.
So Python.
And this second line, sort values by ascending. Always we have to provide this in the form of a list. Means third bracket then cancelled, then third bracket false, ascending equal to by equal to is always we have to provide it.
Very good question. So this will also exclude by see, this will exclude. Okay, but what happens when you want to perform sorting in multiple levels? Let's say first do this, and then do the destination of the flight.
Okay, got it.
Something like this, if you want to do. Then
More than
that
one
is
parameter means in the list.
one
More than one attribute means
parameters
I
in
have
the
to
list.
put in list.
Right. And how do you want to sort them? Defined by this parameter ascending. So what you can do is the count of cancel should be in decreasing order, and then destination should be in, let's say, increasing order. So this should be true, something like this. So right now you are seeing lakhs over here. You will see something actually. Yeah, look at this one.
Yeah.
First preference of sorting is the cancelled column. 9 and 9 you are seeing over here. But if I sort it, after sorting, what you'll see is GRB, since G comes before S in lexicographical order. So GRB will come at fourth place. Let's execute it. There we go. So GRB comes before the other items. So this way you can sort. And this sorting operation has nothing to specifically do with the group by operation. You can do you can call this API on any normal data frame.
Okay, clear.
Alright. See, one thing that is so far is not very great is whenever you perform any group by operation on a column and provide the name of the function, the new name of the aggregated column is same as before, right? And that is not very interesting. So let's say you want to change it. There are a couple of ways to do it. Either you rename the column. In this, you provide a list of actually provide a dictionary. In this dictionary, what is the old column name and what is the new column, right? So what we can write is cancel count. So this thing, right? However, keep this point in mind. After you perform this operation, okay, let me execute this. Probably I'll ask the question. Why is it throwing an error? It is throwing the message is key error cancel. Can anyone tell me why is it throwing that error?
Is it because of np dot some is a function?
No.
See, you have renamed the column, I think so. In the next line, it's
Absolutely right. So at this place, we have renamed the column. Okay, probably I'll explain this a bit. So, see. So now see, you can the column name is cancelled count. There is no column name cancel anymore. Okay, that column has been renamed. Therefore, you do the sorting operation. You have to use the updated name of the column, and therefore you will have to use this. Otherwise, it will not work perfectly. All right.
Sir,
Yes.
sir, here we are sorting by first cancel count and then based on destination error, right?
Yes, it's true.
So first it will take the cancel count will take the preference. So whenever
Absolutely right.
both same, then it will take alphabetical order.
Absolutely right.
So always the first value in the list will get preference.
Correct, correct. So this column gets preference. The first preference, if this is equal for 2 or more entries, then this column will take come into account or take. All right. Let's move further. So we have seen more than one column. Next one we have multiple columns and multiple functions. Name aggregation. Okay. So this is something very interesting. we'll look at named aggregation. And moreover, what if you want to use custom functions? Right? So let's look at that. So tell me something interesting that you want to find out from this. Okay, I think we had this situation where we wanted to do the percentage of delayed flights which got delayed 2 hours or more. So,
Hello, sir.
yes,
Sir, custom functions means we are creating our own functions, right?
absolutely right. Absolutely right. So far, when we are performing group by operation, we are using mean, median, or some function provided in NumPy, right? Or NumPy library. We have not created our own aggregation function, which we are going to perform, and then perform some aggregation. So just looking at where that is. Yeah, there it is. Okay. So I'm going to copy this one. Now what you want to do is you want to get the percentage of flights which are uh, 22 hours or more per day. Now, should be some ideas. Okay, tell me how, if you were to do this, how will you do it?
So we can take the dimension and divide the number of rows by total number of rows in the data frame. That will give us.
So when you divide by dimensions, you will have to do dimension per group, right?
Yeah.
Sir, can we do in the aggregate function like count divided by shape 0?
Count divided by shape 0. Shape 0. Interesting. Of course we can do it, but I have not discussed it yet. How will you do it otherwise? There is a very simple trick. I laid out a hint earlier. How we can do this. That will have the key to this question. So Prashant, when you mentioned that when we use shape and count, we can do it, but the syntax will be different for that. I'll come to that part also. But for now, it is a simpler trick for us. Okay, let me ask you another question. When you provide np.mean this aggregate function to departure delay, then what is the input of this function? What is the type of input of this function?
Float.
Float, are you sure? Let's find it out.
Yes. Yeah. Float.
Let's find it out. The float will be one of the elements, type of every element. Property object is more some less to this. Right? Type of X. And for now, I'm going to do this. So, okay, I'll have to check what is the problem. I'm getting something.
So the type will be same as the type of
Mm, okay, there it is. So the I was sure about this, but somehow it was not printing out. So this is the type for every aggregate function. Whatever column that you choose, that column will be supplied to the aggregating function as a series. Okay, right? And whatever function you right now it is printing, but I am saving it over. But before returning the output, it is printing the type of for every group, and you can see that there are 14 entries over for every group. Right? That means whatever column you are performing the aggregate operation on will be supplied to the aggregating function as a series object. Okay. Now how can we count the percentage of flights which were delayed? 120 minutes or more. New one?
Series, then you can in the custom function, you can put a for loop and then segregate that your based on your conditional criteria. You can segregate, prepare the list, count the percent, and return back.
Great idea, sir. Great idea. Just one modification. Since it's a series object, I wouldn't recommend you to use a for loop because we don't have to. We can really use something like this. T, since it's a series object, T greater than equal to 120, and right? This is going to return a series in itself with true and false. Right? If the delay is more than or equal to 120, then it's true. What we want to do is nt.sum. You want to sum all these counts and then divide by the size of t. Am I right?
Oh, correct. Okay, okay. So I no
Why
need
not?
to establish the loop. Okay.
Correct. There it is. And after you perform the aggregation, what you can do is you can rename the column for better readability. Departure delay to percentage of no better name flights delayed 2 hours or more. See the output now. Here it is. Percentage of flight 2 hours or more. You can see that this is, and also in order to compare, what should I say, the exact count, you can also create another aggregation function. So temp func. Now let me, for a minute, just remove this renaming operation and temp delay. Temp function is over there, which is giving me percentage. This one does not give you this, it will only give you the count. Instead of temp func, I'm going to call something very useful, temp count. Of course, these functions I'm not naming them carefully. Count and there you can see even though AA has most number of highest number of late flights, 2 hours or more, the percentage is not the highest. It is 2.3%, but you can see others have 4%, 3%, and so on. You can sort them. Now see, columns are multi-index, they are multi-levels, so using them is not easy. Now instead of that, I'm going to introduce you another syntax, which is named aggregation, which is very, very useful. Alright. So we want to use departure delay multiple times with different functions, but the names should be. So let's do that. So I'm going to comment this one out. This. Right. So here you write it like new column is equal to pd dot name agg. Okay. Then column name comma agg function. Frequency is equal to some function np dot. Okay, this is the syntax. So this column name comes from the column in the one of the groups after the group by operation. This is the column name that you want to. This is the new column that you want to create after group. So this is how it works. And now let's apply this on departure delay. So departure delay is the column I want to apply my aggregation function, and the aggregation function is let's say temp count. Something like this. And the name of the column I'm writing like late flights. Okay. And of course, I want to perform this aggregation, this type of aggregation multiple times, so I can repeat this. Instead of late flight, I'm going to call percentage late flight. Percentage late flight. Aggregation function is not temp count now, it is temp count. That's what I'm going to write. Now let's explain this. And there it is. You have late flight and percentage late. Of course, when I am performing group by, I have not as complex false. Therefore, line it's not. You can again sort them by sort values by, let's say, percentage late flight, but in decreasing order. So there it is. Even though there are 7 flights which were delayed, but only %. Yeah, the highest one is this one. United Airlines maybe 3%. You can also create another column, flight count for your convenience. I'm going to check that one. Same. Yes. Flight count. Just np dot sum, not sum actually. Np dot sum. Or you can write some simple function like lambda x will be the series of departure delay and return lambda x. Okay, that should do it. So the output now is late flight, total flight count. This is the total flight count for that particular airline. This is the count for late flights, and this is the late. Any questions so far? No? So multiple, yeah, is one thing that is custom aggregation, single multiple columns will be respective to group by object. Also, the only thing which is remaining for group by is how to perform group by aggregation when the aggregation logic is based on multiple columns, not just a single column. So far, all the aggregations that we have seen is based on a single column. Whether it's named aggregation or without named aggregation, always the group by operation, aggregation operation is based on single column. Okay. What if you want to perform the aggregation based on multiple columns, but produce the output or produce this only a single column? How can we do? Okay, so let's see that. So this is our data, price data. This thing can be what aggregation based on multiple. Okay, what about this? We want to find out the flights per airline which were late, which started late and reached the destination late. So, okay, sometimes it is possible that some flights they departed on time but landed late or vice versa. But if some flight departed late, then it is likely that it's going to arrive also. And that's what we are trying to. That is a multi column based logic for aggregation. So let's do that. Group by airline. Okay. Then there is this function which we have already covered, which is called apply. Okay. And this function is going to take this API apply function. Okay, is going to take a function which will operate on a data frame per group and will produce the result. Okay, so let's do that. Def date departure and arrival. Here and here, DF is the data frame per group. Okay, so keep this point in mind. We are going to pass this function over here. Okay, and this data frame will have the entire set of records for every airline value. So we have to count the flights which started late as well as departed late as well as arrived. So departure delay for such flights should be greater than 0, right? Of course, I cannot take this. And arrival delay is also greater than 0. Okay. And I need to count this number. So either I can use something like dot sum, because it's going to be a Boolean array, and it's in the output, which is count of letters, which is started late and reached late, and return this one. That's it, right? Plot this. There it is. So for every airline, number of flights which departed late as well as arrived late can get counted. Now you might be saying that this is this though looks good, but this is the output is actually a series where the airline is the name of the series and the name of the airlines are index and the values are represent the interesting number. But the important thing is the output is a series, it's not a data. So again, one thing by which we can fix this is something like this. However, the second problem still remains the name of the column. Right? It is not. It's not. In order to fix this problem, we have to see this apply function. It's very interesting, by the way. Can not only just perform the aggregation and produce one output, but it can produce multiple outputs, and we are going to see that. So let's say what I want is I want to name this part. Of course, you can call the name something like this. You can do. So after apply, you can call rename, but I would not go there for now, because you know the trick already. There is something new that just go on output for now. Output pp dot series. And here you will have to produce the name of the column versus the aggregate type. So you are creating a series basically. And what should we call this? Late, depart, and arrive. Let's see. Something I'm missing. This is addition. This is series. Oh my bad. Series which techniques. It's not producing output. The reason is the output stream not. There it is. Date departure. Now, good thing about this apply function is, as I mentioned before, not only you can produce just a single aggregated value, you can produce multiple aggregated values. All things that we were doing earlier. All of these things can come. So again, all this unpropagating entire thing, and we'll change it now. All these name aggregation things will go out that are not needed anymore. Okay, something I can do. Take flight. So now what I have to do is apply this function on this column of the data frame. That is what I will have to do. Something like this. Temp count is done. GG function. Okay, I can just use df dot shape 0 I can use count. Something like this. And in the output, when I'm producing the output, I have to provide all these new items as well. So write down, percent of date light, that's it. Count, this is this. So now what's going to happen is we are creating multiple columns, 1, 2, 3, 4. One of them is based on the data of multiple columns. Others are based on a single column partial delay, and this one is just shape of the group. Yes. So everything you're getting inside this. Any questions so far?
Yeah, sir,
Yes.
in the second one, here output is equal to PD dot series you are writing, but you are in the
Yes.
series you are providing more than one column. So I thought it will be a PD dot data frame.
Okay, good point. Good point. See, first of all, they see. Look at this. These are just singular values. They are some numbers, right? Some fractions or some numbers. 1, 2. They are not list. They are not iterables. They are just single values. And when you create series like this, what you are doing is you are providing you provide the dictionary. The key values are the index values, and the values will appear in the series as single column. Okay, so let's see this. If I just copy paste this one, okay, and let's look expect it separately. I'm not sure if it because they are not defined outside. So I have to write some numbers. 1, 2, 3. There it is. So I'm getting a series. These are the indexes. Right? Series. One series of and there it is. So these are the index values. Make sense?
Yeah, but in the above table, these are actually not the index. These are actually the column name. Index is something else.
You are right.
Uh,
You're
that
right. But think, see, you're right that these are the column names for every pair. But think about this. For a minute, just ignore other groups. Okay, just think about this group AA. Okay, just think about this group. So when I'm aggregating for this group, alright, I want to create the columns. These are the columns that I want to create, but I want to populate single values for every column for this group, right? And there are no list of things. For every group, I want to populate a single value, and this is the format we provided them. For whatever group this function is called, okay, create these columns, okay, and these values are populated as cells in those columns.
what is the type of output? It will be a
Series.
series. I
Yes.
think. Yeah, you are creating series main series. Okay.
Any questions so far? Anyone?
But they are still column names.
Yeah, they are column names. Basically, this will get translated into column names.
So, but if you just do pd.series, it is the row indexes.
Correct. But see, for every group, we are providing this series, right? We are performing aggregation. you're applying this function for every group, right? Make sense?
So they're becoming columns.
Yes, they become.
So, but the same thing can be achieved using aggregate function.
How will you achieve this one?
Yeah, it is a custom function.
Yeah, this one. So this aggregate quantity count of flights which arrived late as well as departed late, they are dependent on two columns, not just a single column, right? Of course, you can do it. The reason is you can create another column in the data frame itself by this logic, and then get a count of it per group. That is possible, but this is cleaner. This is do not create any unnecessary intermediate columns and just do not pollute the original data frame with unnecessary columns, temporary or intermediate.
Okay, and each time the DF is called, it will correspond to one airline.
Sorry, Prashant, can you repeat that?
So whenever this function is applied, the DF will be the data frame for each airline.
Yes, yes, absolutely. Any other questions?
No, this part clear.
Great. Run custom aggregation, run single multiple as well. Multi-level indexing. Aggregation part is done. So we are through with group by. No, this much I think there is. I cannot think of any kind of aggregation that we can do. Let's move on to next topic. This one, combining multiple data frames vertically based on a column or multiple columns in a router and 6. For this, let's use our simpler data. So this is your data frame. Let's say you want to let's create another data. Some let's create DF1, and instead of Tata or manufacturers are same. Tata, let's say write Indigo, Indica, Maruti has Brezza also, BMW, let's write Plus. Manufacturers model pricing less, but price is going to change. Let's say this is just 7 lakhs. Teresa is 12 lakhs. We are imagining 40 lakhs, something like this. Now, here is our original data frame. There were some models, and there is new form. Another data frame, there are certain models. Something. Now, imagine that you have data frames from multiple sources, and at the end, basically, they belong to the same data or same set of observations. That means the records have to be merged into a single data, and we are going to look at how we are going to. So one of the easy ones is the vertical concatenation, putting one data frame below the other. In this one, we are going to assume that columns in both the data frames are same, and shortly we will look at the case where columns are not same. So the method to do this is pd dot concatenate. Okay. And here we are going to mention as a list or a tuple the data frames that we want to concatenate, and access the direction in which we want to concatenate, vertical or horizontal. So I'm going so the axis is going to be 0. Let's see. Concat something. Name is concat. So here you can see that now you have a single data frame, df1, df, axis is 0, and this is the output. Right? What happens when one of the data frame has an extra column or both of them have different columns? Let's try to do that. Manufacturer, model, price index. Let's say we add another column which is called date of manufacturing. So this, I'm just adding random dates. 24, 09, 2000. Or instead of that, let's say model year. That is sensitive. Here. So this one is let's say 2020. Reza is 15, something somewhere. So if I make some mistake, there's a problem. How it works. If I look at the file, I'm getting model year. Okay, all of them. 24 September, but the years are changing. Very bad randomly generated numbers, but stick to it. So it's 0 to 13. This one is 6. So these are data frame looks like. And now if you concatenate them vertically, let's see what's the output. So you're seeing that all 4 columns are present. Even even the column is added even for the data frame which did not have that column, which is our original data frame did not have that column model here, and therefore even though the rows from that data frame are concatenated for this column which did not exist in the original data frame, or the column values are not present. Okay. And similarly, if some column were not in F1 as well, that column will be populated as 9 for the rows coming from here. Let's look at the next one, next category. Based on a column or multiple columns, and so basically these two things are together. And now we are going to join multiple data fields. It is very similar to the join that you must have seen in database management system, relational databases, where one of the columns or one or more of the columns act as foreign key for a table. So let's do that. So for this, let's create something, some one something. Is this? Let me get another data frame 2, which is pdf1 dot copy is equal to 2. But I'm going to select certain models. For example, model. I'm going to select model, and that's all. I'm going to create another column. Model here is there, pricing also is there, which is missing engine CC. Let's say Indica contained only 800 cc engine. Visa has 1500 cc engine. Other class has whopping 3000 cc engine. This. Now you have this DF2, and earlier you have DF1, which is something like this. Now, what you want to do is you want to find out, let's say, let me add a few more. So, what basically you want to do is you want to find out price per cc of a particular car. Let's something. Let's try to do something like that. That means how much power are you getting? How much money do you spend per cc of the engine? Because the cc or the engine volume is related to power generated by the engine, and hence how powerful or performant the car is. Therefore, how much you have to spend per performance unit or per cc, that's something you want. That means price per lakhs divided by engine cc of the engine size. Now, in order to do that, see, could not be done at this moment because this engine size resides in a different data, and this price underscore lakhs resides in Hungary. So in order to make sure that we can do the operation, we can do price underscore lakhs divided by engine cc. First thing that we'll have to do is we will have to combine these two data frames such that we yes, in this data frame we get another column called engine cc, which is coming from DF2, and correctly that column should be populated correctly as well. That means in front of Indica there should be 800, in front of Deza it should be 100, and in front of Z class this is 3000. Okay, let's say this is what we have. Okay, so when I copy, this is how it got, but sort use by one. Sending equal to or when it is sending, that's fine. This is your DF2. If I see this, Okay, Beza has 800 now, Indica has 1500, but Z class is still has 2000. That's fine. Okay. The reason I changed the order over here, Beza, Indica, and Z class, because I want to show that when we are performing this join operation, it doesn't matter what is the order of values in a particular column that we are using join. It's going to do. It's still going to do like so. There's one more thing that since we are
Sir,
at
but when we use sort function, the engine CCs got changed.
you're right. Each is that. That's fine. Should be 800 over here or 300, right? But this yes, reset index of okay. See what I have been doing is you can see that after you perform that sorting operation, the indices are messed up 102. Instead of what I want is 01. So I'm resetting the index and dropping it at the same time. You just remove the index column and populate it with the new. That's all. Okay. Now let's see 01 and 2. Now let's go to the original operation that we performed, which is combining df1 and df2 based on this column. Column is model, which is will act like a primary key and a foreign key for this pair of data. Now, for the operation is pd dot merge. Then you mention there are two ways to do it. Actually. Let's look at what df dot merge. Are we merging df and something else or df1 and df? We are merging df1 and df. So df1 merge it with df2. And what column to use? The column to use is model. There it is. So Indica got correctly mapped to 800. Reza got correctly mapped to 1500. Z class correctly got mapped to 3000. Okay. Does that make sense? Well, there's an interesting thing. More often than not, what's going to happen is let's say df2. Somebody changes the name of the column. He or she writes instead of model, capital M model. Okay. See to this. Now if I try to merge them, no error. Why? Because the model column does not exist in the second data frame, which is 0. Then how to do it? Okay. For that, what we'll have to do is we have to mention the column the key column in the left data frame and the key column on the right data. Now which brings to the next syntax. td dot merge. Now you can think of these two data frames as two tables. One is sitting on the left hand side, one is sitting on the right hand side. Okay. So this is how we can write it. Left data frame is here 1. Right data frame is here 2. Okay. And then what we'll have to mention is the column from the left data frame and the column from the right data frame to use in order to merge them. So left is for all is model. That one is still small m. And the right column is capital mod. See, and here you can see that model, Indica is currently mapped to 800. Reza is currently mapped. Z-class is currently 3000. However, there is a problem now. Problem is this model column is being repeated. So what you can do is, of course, you can either what you can do is cycle checker. You can drop one of them. And one of those repeated columns are gone, and this is how you can do. Any questions so far?
So what happened when if the model name is different, then it will be an value.
Very good question. That was the topic of few minutes. Let's do that. So DF1, DF2, okay. So I'm making a copy, and this is how it looks like. This is DF. Now let's add another add a row. DF2 dot log, and then 2 is equal to, I'm inserting a new record into this, and it must have three things. Not three things actually, there's only two columns. No? The model name and engine CC. Let me add some new carrier, and there is the engine sizes 1000, yeah, 2 liters. Okay, let's do that. Execute this. Let's see if it is populated there or not. It is there. So carrier 1000. Now let's say we are performing the knowledge. So the Harrier value, Harrier model is not being incorporated. The reason for that is there are three or four types of merges that you can. By default, how is the parameter which decides how you are going to merge it? By default, it's similar, and that's why you are seeing the output. That means it's similar, very similar to inner join that you perform on databases, database tables. If a certain value for is present in both of these two columns, in both the data frames, key columns of both the data frames, then only it will be in the output data frame, otherwise it will not. Okay. If I do left, then for all the values in the key column of the left data frame, there will be a row in the output data frame. However, it doesn't matter if the right data frame has that value or not. If it is right, then it is just the opposite. And it is outer, that means for every unique value, the key columns of both the data frames, there will be a record or row, the output data frame, no matter whether it is present in the other data frame or not. Okay, let's do this outer, and there you see. So engine CC is coming out to be 2000. Now, since we are doing outer, I think we should not drop this copy. See this one. Now, the three models which are present for both the data frames, Indica, Breza, and Z-class, you are seeing all the values are common. But for the model Harrier, which is present in the right data, is absent in the left data. There is nothing. Correct? I can do one more thing. See, data frame 1, where we are there, right? Data frame 1. I can add one more thing in here. For example, Mahindra. Mahindra is another manufacturer, and it has produced Scorpio. And the price of that is, let's say, 5 lakhs, and model year is very recent, let's say 24, 11, now look at data frame 1. There are 4 entries in it. There is one from Mahindra as well. Now let's see the output of every type of job. We do inner. You've already seen this. There are no in the key column, the model column. There are no missing values. If you do left, here you can see that when we do left join, that means all the key values present in the model, there will be a record over the output. Mahindra was present in the left data frame, but it was absent from the right data frame. Therefore, these 2 columns are not populated for it. But you also notice that Harrier is not here. Right? Harrier is present in the right data frame, which is data frame 2, but it is not in the output. What if we do the right join? Something like this will appear. Means this time Mahindra's row is missing, but Harrier row is present because this model Harrier is present in the right data frame, but is absent in the left data. Therefore, this is the output. If you put it right, all the unique rows, all the unique values from the right data frame to the column will be populated in the output. Now the last one, which is the outer, and in this one we are going to see Harrier as well as Mahindra Scorpio, but you can also notice that since Mahindra Scorpio was not present in the right data frame, therefore the columns from the right data frame are populated as null, and similarly Harrier was not present, therefore columns from the left data frame have null for this. Make sense?
Yes.
Any questions so far?
So if you calculate one more column, that is the price per engine capacity, will there be any error in this case?
Yeah, there will be. Okay, I'll definitely show this. I'm going to save it as a T data frame, which I'm not going to do. Or that's not. But price TC, then price Mr. TC. Yeah. Let's define another column. Price per CC. See, this NaN basically means it is missing or not a number. And for whatever operation that you do involving that column, it's going to end itself. So let's do this. Price GCC. Yes, it works. It is not going to turn out or throw an error, but this is the output you will see. See, price per CC, you are spending I should multiply it by. So here you can see that you are spending nearly 1,300 rupees for the BMW, for 875 rupees for the, but for the rest of the two trees, Mahindra and Harrier, for Harrier the price was missing, and for Mahindra Scorpio the engine CC was missing. And therefore both the values are anyone.
Yeah,
Make
okay.
sense?
Mhm.
Any questions so far?
No, no, sir.
Let's move forward then. So this is the last topic in today's workshop, which is how to make the data
So
tidy.
can we take 5-minute breaks?
I'm happy with it as long as everyone else is okay.
Sure.
All right, all right. Anyway, this is the last topic. We are not going to pursue it.
Sir, the pivot here is the same in the Excel, the concept
Pivot is same as the
that we do in Excel tables.
yes, it's good.
Okay.
And melting is just the opposite of it. So both of them are opposite operations of each other. In some cases, they are not reversible. In most of the cases, they are reversible. Okay, so
Okay.
let's take 5 minutes break and then we'll start. Hello, am I audible?
Yes, sir.
Yes, sir.
Okay. So for the next couple of tasks, writing and predict, I'm just creating a imaginary happening. Then let's say the Apple production, every state that uses, let's say, metric ton, something like that per year. MP, there are no UP, maybe 1 metric ton, Tamil Nadu, no apples, I guess. Then there are bananas, MP, let's say it's 1, so Tamil Nadu, it's 5, UP, it's 2. Again, these are just imaginary numbers. One more to production. Apple, bananas, say, 5. MP, 2, 3, something like this. So this is how your data frame. Now, many of the times, what you'll find is your data frame is in not correct shape. When I say shape, what I mean is the column names, the columns are column names are actually values for a particular variable, and the cells are again those are just value of production. But the column names, instead of having those columns as names, we might want to have a single column name, let's say called fruit, and the cells could have the production capacity, something like that, instead of having something like this. In such cases, what you want to do is you want to reshape or transform the data. For this particular operation, where we want to convert the columns as columns as a single column, you want them to appear into a single column, and these values might appear in another column. In such cases, what we are trying to do is we are trying to melt the data. So let's take a look at the documentation for this. So df.melt, whatever data frame that you want to melt. ID vars is the name of the column or set of columns which you want to retain as they are. You do not want to change them. Value vars is the name of the columns or set of the columns that you want to appear as a single column. And there are two more things, value name and variable name. So once you put all the new old columns into a single column, what will be the name of that new column, as well as what will be the name of the new value column. Okay, so this is the syntax that we're going to follow. Let me just copy this one. Of course, there are more options, but we can. Okay. Okay. So data frame, right? Okay. So this is the format. ID vars. That means the column name that you do not want to change, and that one is the state. You want that to stay exactly same. You do not want to merge that with anything else. So state remains the same. Value vars. That means columns which we are going to merge together. So, we are going to merge apple, banana, and oranges. Variable name. After we merge them together, what should be the name of the variable? Let's say fruits. And value name, let's say we want to write it as passive. And let's perform this operation. In there you go. Empty, it produces apple. The capacity is 0. You can confirm all of these values from the original data frame itself. MP produces 0 apple. And UP produces 1 apple. So UP produces 1 apple. And so on. You can confirm actually each and every entry. And here you can see that you have reshaped the data frame into the way you want. So basically you are reducing the columns. In melting, they are reducing the columns and increasing the number of columns. And this is how you do it.
So what do we gain by this?
What do we?
Gain by this.
Well, it is the need of the problem. So in case you want to do something like this, it's an option which is available. So you need to melt so let's go back to some. Some other CC. Let's take a look at D. So DF2 right now it looks really good, right? This is how it should be. But what happens if you have a data frame which is in proper shape? So I'm trying to see. So that this. What if these are Z class variable where column names instead of so let's create another imaginary data frame. These are and CC is CC is how much? Next is Indica. CC is 800. Next is Z class. CC is 1000. Strings. Relief. CC is 2000. And PDF2 overshoot. So let's say somebody recorded the data, but something like this. So instead of creating a single column and with model names as the values in that column, somebody created those individual values as column. Reza, Indica, Z class, and so on. This is a very trivial example, but if somehow somebody recorded the data in the format that is not suitable for your application, then you will have to convert this into more suitable format. In this particular case, you will have to apply melting operation. That means you want to convert these columns into a single column, and the you have to give it some name. So for example, you can look this. There are no ID vars, so we don't have to put it about it. See, since there are no ID vars, I think you can just have it to false. There it is. Value in variable. Since we have not mentioned what is the column name and what is the name of this value column, therefore this is how it is done. Make sense? Hello? Hello? Am I audible?
Yes, sir. Yes.
So I hope it is clear. If it
Yes.
is not, let me know. I'll just I'll explain it one more time. All right, let's move on to the last topic then.
So can we also use transpose?
Transpose is not always the answer. For example, in this case, you cannot transpose that and create.
Yeah, not here.
Oh, so one thing is we have done. So let me save it in PDF. The columns. Let's look at. Now I'm going to show you the reverse operation, which is the pivot operation. So this is the melted here. Now, what if you wanted to convert, you wanted to do the opposite operation? That means you wanted to convert the values in a particular column into individual columns, and whatever the capacity or the next value, you mention the value columns also, and then populate it accordingly. That means you want to convert melted DR into this data. Basically, that's what you want to do. All right. So in such cases, we perform the operation pivot. Now let me show you how. So we melted div dot pivot. Columns that you want to make new columns. The column that you want to make new columns from. And typically this is the most important one. Index is the column to use. Index, no, that's not for now. And that's all. Let's see this. Pivot. Melted. Columns is equal to fruit. Something is wrong. None of the some mistake. So this fruits. Right? This. So state. Yeah. Now there is one important. Not mention the how to fill up the cells, no? And that comes from the values. Values are coming from capacity. something I'm making mistake of. Index must come. Yes, right. So this particular parameter is very similar to what we were seeing as ID vars in Melting, right? Column which remains the same is being used. Okay. It is being mentioned as index in the index. State, apple, banana, is the output we are doing. Okay. Of course, what we can do is we can reset the index to get this one out as a column and convert these columns, multi-level columns into single. State groups in capacity. This is method. Pivoted. This is index. Start. Missing something. It's fruits. Where it is coming? Whether it's part of index or column. See? Okay. All right. So fruits came out to be X. I'm not very sure about how this fruits is coming out to be over here. It should have been gone because we are using the values from that column, populate the new columns, and the state which was becoming index, we have removed it and formed the part of the set of the columns. This is getting as the name of the index of fruits. Rest of the things you can actually match that this is exactly same as the values in this data frame, exactly same as that in the original data. This one. MP012, UP153, Tamil Nadu 02. MP012, Tamil Nadu 021. Research index again. So the name of the index is not the the rest of the values are same. So fruits column out of which we are creating products, that name goes into the index. So this brings to the closure of this workshop or closure of this session as well. Any questions so far?
This last 2 days video is required.
Hello?
The recordings of these last 2 days, your sessions is required.
Right. It will be populated in the same playlist as the one that we have shared in the chat space. And when as soon as it is populated, I'll form in the same space.
And when the assignment will come?
So you can expect the assignment at most by tomorrow evening. It will be populated for you to solve. Certain number of days will be provided to solve the assignment and submit back to us. The assignment will be evaluated and you will have to score 80% and the passing criteria will be mentioned in the assignment itself.
Okay.
So we should complete some 80%. Right?
Yeah,
Of
you
each.
have to score 80% or higher to be eligible for certification.
And there will be 4 assignments.
There will be 3 assignments, one on Pandas, one on data visualization, and one on Colab. I mean, 3 sections in a single assignment. The assignment is only one, but there will be 3 sections. Any questions? Questions still regarding?
Hello,
Sure.
hello, sir.
Yes. Yes. Please go
So
ahead.
I had a question that after means we have covered pandas here, and so how can we means what kind of projects that we can now further do with
See,
this
right. If you have, then you have
on
come so
Kaggle
far.
or
See, I would not suggest that you go on to Kaggle just after taking Pandas. Of course, knowledge of Pandas is necessary to participate effectively in Kaggle competitions. However, so far we have only learned data manipulation, data massaging, data, uh, so on and so forth. But we have not learned machine learning. So that's a different topic. In Kaggle, you need both data manipulation skills plus machine learning skills. So I think at this moment, again,
okay.
there are many operations in Pandas. For example, I'm not taught you shifting columns, how to perform time series analysis, which is typical of many of the data sets that you will find out here. And as an interesting note, Pandas was created for originally it was created for performing time series analysis. So that part we have not covered because that's going to take a separate uh, workshop altogether. There are a few more things that I have not covered. For example, how would you uh, data visualization with pandas? So pandas can be easily integrated with many of the data visualization libraries. Plotly you have already seen, I know. You have not seen, I think, Matplotlib or SMS. How you can create subgraphs with pandas. Basically, integrate pandas and uh, Matplotlib or SNS. That is one I have not covered in detail. Some of data visualization with pandas was covered earlier in the session. Next, what I have not covered is debugging with pandas. Let's say you create a big data pipeline which takes many number of files and produces analytics or statistics insights for your project. In that case, what happens if somebody changes the format of the data or data type, something is missing, something is not right. So what you want to do is you want to set ground rules for loading any pandas data frame. So when you set these rules, it is you can find these rules or setting these rules in a package called Great Expectations. It can work closely with Pandas with that package or with that library, Great Expectations. You can create certain rules for your entire project, data line, data ingestion pipeline, so that whenever certain rule is missing, let's say you are processing scores of an examination, and for some student the score is coming out to be 130, which is absolutely not possible because the maximum score could be 100, and this is what you know already. So you can set a rule. So whenever this rule is broken, uh, whenever and then you're reading the data or setting processing, it will generate some kind of message back to you, so that you know something is wrong with the data. So you can debug your data as well. So these are some of the topics that have not covered in these 2 sessions because they're going to take a few more sessions and workshop. It could not have been covered in the small workshop blocks.
But sir, have you taken any this kind of workshop with the previous batch or anywhere else? If so, if you can provide us the link, we can go through.
Yes, this kind of workshop was taken in May 2023 last year. I will post the playlist of that workshop also in our GSPs. However, at that time, Pandas was not covered in the great detail. Had only two things: introduction to visualization and introduction to Google product.
Okay.
So, sir, you talked about many things that we have to learn that is not covered in this
Correct,
short
yes.
workshop. So, where can we find certain resources so we can carry forward our journey of learning new things in machine learning and analytics?
Okay, sure.
Certain
So,
websites or sources. Yeah, thank
see, websites, I'm not sure. I've not gone through any websites. However, there are certain publications which I'm very fond of. For example, O'Reilly and Manning. So, if you want in-depth knowledge of
Sir,
pandas,
can
really good
you
knowledge.
repeat those names?
Yeah, O'Reilly and Manning publications. Let me write them in chat space.
Yeah, can you write it in the chat box because the voice pronunciation is not getting clear in the audio.
So Manning and O'Reilly, they in general publish very good quality content. Not only just pandas or TensorFlow, but variety of things they publish. And what I found is they publish very quality content. So Manning and O'Reilly, there is a book by Manning, okay, which is Pandas Workout, which I think is a very good book for starters. That is one you can refer to. And at the end, see, all boils down to practice. There are many APIs or functions available in Pandas library that you can use to manipulate data, which are not covered today. And believe me, there are very good applications of those APIs. So go ahead. I would strongly recommend for you to go ahead, get some good books, practice. There is a book called I forget the name. It's Pandas Workout. That's the name of the book, which has good exercises for you to practice.
Sir, excuse me.
Yes,
Sir, are there any plans for MLP project bootcamp or any other workshop upcoming?
there are a couple of more workshops which are coming. I think both of them are uh, on transformers, which is a deep learning model, which is getting very popular. The model which is higher in Chat GPT and so on and so forth. Many popular applications. Therefore, we have to workshops on transformer. One on I do not know the names of the workshops websites, but I'm aware that they belong to transformers. One is on Hugging Face, and the other one is on transformers. But I think in due time, the names and further details will be also published.
Okay, thank you, sir.
Sir,
Yes,
sir, you told about practicing about pandas problem. Which book have you mentioned? Can you please write in the chat box?
sure. I think its name is Pandas Workout.
And sir, you talked about this transformer model and another also I'm hearing diffusion model. So what is the basic difference between those?
See, Aditya, I'm not the right person to talk about diffusion models. I'm not
Okay.
aware of them as well. But transformer
Okay.
models both of them are kind of deep learning models. our transformer models are based on this paper, which is called Attention is All You Need. It was published by researchers from Google and has done wonders for many machine learning tasks. Natural language processing is definitely being kind of NLP tasks are reshaped by this transformer executive of this model. ChatGPT, Gemini, many more large language models are based on transformer.
When this workshop will conduct this transformer?
Can you repeat that, Samir?
When this workshop for transformer will come?
The next couple of workshops, I think one of them or both of them are going to cover transformer. For sure.
When?
The timing, further details, I don't have it because some other teams are handling it.
Those workshops are going to be by NPTEL or